好，所以我们等一下还会看一些例子。We'll look at this first example. 下面按掉。The first example is 1, 1, 1, negative 1. What are the eigenvalues of this matrix? Also, before that, maybe we want to recall how to determine the eigenvalues. Does anyone remember that? Okay, tell us how to determine eigenvalues. Good. So, determinant of lambda identity matrix minus the matrix A that we're working with, and solve for this equals to 0. This is also the same as looking for so Bk is, well, maybe not K, but we are looking for 0 solutions of this. If we want, we are looking for solutions to this homogeneous equation. Homogeneous means that the right-hand side is 0. And if we want phi to be a non-zero solution, 就是非全零的解的话, then determinant has to be 0. Otherwise, the only 0 solution is always 0, the 0 solution. That's why we solve for this equation to find the eigenvalues. Now for that matrix 1, negative 1, 刚刚那个正。还是看这个。好，然后so the eigenvalues of this is lambda minus this, and determinant of that is equal to lambda squared minus 1 minus 1 is lambda squared minus 2. So the eigenvalues are what? I 就把刚刚的方法带进来嘛，然后算 eigenvalue 等于是相异还是相同的值？看不太清楚。What are the eigenvalues? So if we solve for this equals to 0, the eigenvalues are plus and minus square root of 2, and that's what we have on the slide. Okay, and the eigenvectors, are they the column vectors or are they the row vectors? Of which one? This one or this one? 所以刚刚我问的就是eigenvector 是航向量还是那个列向量？然后他回答是航向量。那是哪一个矩阵的航向量呢？ Well, they're the same matrices, so either one of them, right? And just because this is what each of the phi is one column vector. This slide again, it explains geometrically that when we have an eigenvector, then the vector is not changing directions after the transformation A. If the eigenvalue is less than 1, then it just flips into the negative direction. If the eigenvalue is greater than 1, then the length of the transformed vector will become longer. Here we have one of the class of matrix that I mentioned called the symmetric matrix. And for symmetric matrices, we not only can always diagonalize them, we can also make an orthogonal diagonalization. So orthogonal diagonalization is 正交对角化。正交对角化的意思 what do we mean by orthogonal diagonalization? For symmetric matrices, we can always perform a orthogonal diagonalization. What's an orthogonal diagonalization? Anyone?那个有水杯的同学，
就转置就可以得到inverse。
因为转置等于它的 inverse， 正交矩阵的话，转置等于它的 inverse。So for an orthogonal matrix, the transpose of the matrix is its inverse. Therefore, the diagonalization means that A can be expressed as vector P dP transpose. What kind of, okay, and also eigenvectors, it means the eigenvectors of the matrix are orthogonal to each other. 就是这些特征向量或两两是垂直的。下一个那个。